I saw your problem. It's one of my favorites in Trig, so I figured I'd try to help. Hopefully this is helpful. I'm assuming you already have kind of a basic background around the characteristics of trig graphs, amplitude, period, things like that. I'll talk a little bit about them. But first, I want to just go over the very first part of your problem. I'm not going to answer all of them, but some of the most important parts. And the first part being, what should this graph look like? If we're trying to graph height related to time on a Ferris wheel, in my opinion, it would look something like this. So we'd start down here all the way at the bottom. Technically, you should probably start like 2 or 3 feet above the ground if you're on the ride, but for our sake, to make it easier, let's just pretend we're on the ground. So we would start on the ground, and then as the ride starts, we would start to get higher and higher and higher and higher. About midway, the speed with which we're rising would level off until we eventually reach our maximum point at the top of the Ferris wheel. And then as it comes down, we would just do kind of the mirror image of that until we finally reach the ground again. And then that same thing would repeat. So we'd do kind of the same thing over and over. Granted, my drawing is terrible, but hopefully you get the picture. And so in a problem like this, anytime you're dealing with the Ferris wheel, it's going to be a sine or a cosine function. And our job here is to build one of those to represent what we've just drawn. So really quickly, the form of either a sine or cosine function, I wrote cosine here, but it could just as easily be sine, is generally a times cosine of b times your variable, in this case t, minus c, plus d. So there's lots of variables. Remember that a is the amplitude, which is half of the distance from your max to your min. D is the midline, so whatever value is in the very middle of your function. B helps to find the period. It isn't the period itself, but it helps to find the period, and that's how long it takes for the function to go from one minimum to its next minimum, or from one max to the next. And C contributes to what's called the phase shift, which is how far your graph moves left and right. The midline, the D, can also be called the vertical shift, how far it moves up and down. So in this case, it would help just kind of get a sense of what those numbers should be. We need numbers to begin with. I'm going to just say, to make it easy, that the top of the Ferris wheel, we stop when we get to 100 feet. That'll make it easy. And that'll also make it easy to find our midline and our amplitude. So our midline D is halfway, it's the halfway point from top to bottom. And so in this case, halfway from 0 to 100 would just be 50. So our D here would be 50. The amplitude, again, has to be half of the distance from the top to the bottom. The total distance from max to min is 100. Excuse me, half of that is also 50. That's not always the case in these problems, but in this case it will be. So A is 50, D is 50. Now let's just start there, and the rest that'll make the rest easier. So I'm actually going to show you on this software called Desmos kind of what that does. So if we start with just a basic function, cosine of x, I'm going to go with cosine. You'll see why here in a minute. That doesn't look too great. Let's add on the 50 for our amplitude. And already you can see, I don't want to move it, but you can see that the graph got a lot taller and a lot taller both up and down. And then if we add on the plus 50, so all I'm doing here is I'm putting the A, the 50 in front, the plus 50, our D at the end. And you can see that this already looks a lot more like the picture I drew just a second ago. It goes all the way up to 100, comes all the way down to 0, doesn't go beyond those. Hopefully you notice though that one big difference is that our graph starts at 100, or this one does, and the one we drew started at 0 at the bottom. We can fix that really easily by just putting a negative in front, and that will flip the entire thing upside down. So now we have something that looks quite a bit like the graph that we drew, using just the amplitude and the midline. Also important to notice here, remember back to when I said the C was the phase shift, it moves things left and right. Well, in this case, we don't actually need a C because our graph starts exactly where we want it to. If we were to subtract a number, any number, right, it would move the graph in a way we don't want to move it. We want the graph to start right there at the origin. And so the phase shift in this case is actually just going to be 0. So that C will be 0. So we've got this thing almost entirely figured out. I'm going to write that out here. So we've got f of x equals 50 times the cosine of b, we still don't know b, times t, plus 50. Or excuse me, we can get a negative in front to make sure that graph is upside down. So that's what we got so far. And if you noticed on Desmos, I put an x for the variable. That's just because Desmos doesn't like t. But same difference. Now this, I think, is the trickiest part. And it may not be something that's obvious to you. But if you go back to that graph from a minute ago, I want you to think about how long you want this trip to last, right? So if we start here at the origin, we're at the ground level, we just got on the ride. How long do we want it to take until we get to the bottom again? Maybe 5 minutes, I don't know. Let's call it 5 minutes. But on our graph that I showed you a second ago, that is not what we have. And in fact, looking back at it, we start here at 0, and we have the next minimum here occurring at 2 pi minutes, which is like 6 point something. I don't know, but it doesn't really make sense in the grand scheme of things. So what we're going to need to do here is figure out a reasonable value for b so that we end up with the 5 minutes we want. So we want this minimum here to land at 5. This is where our formula for period comes in. Remember, period is this distance from minimum to minimum. Hopefully you already know that the formula for period is 2 pi divided by b. Technically it's the absolute value of b, but we're going to assume it's positive here. So the easiest way to do this in this case, so if that's our formula, whatever you want this value to be, the end of your period, we're going to set that equal to the period formula. And this is going to help us solve for that b value. So we want our period, 2 pi over b, to give us 5. To solve this, if you multiply b on both sides to get it out of the denominator, you'll get 2 pi times 5, or excuse me, 2 pi equals 5b. Divide by b on both sides, and you find that b would be 2 pi over 5. That is not the period. That's not the period itself. We want the period to be 5 minutes. But to get that period, this tells us that our b would need to be 2 pi over 5. And you could do that with whatever you want it to be. If you don't want it to be 5 minutes, if you want it to be 3:10, who cares? You just substitute that number here for instead of 5 and solve it the same way. So last thing here, that means that given the graph I drew, and I chose a bunch of numbers on my own, but given that, our final equation would be f of x equals negative 50 cosine of, now we're plugging in the b, so 2 pi over 5 times t with our 50 at the end. So that's the final equation we would end up with. It's kind of weird to see that 2 pi over 5 in there with the t. It's not just a number. But from our formula, that's what we found out it needed to be. And I want to show you, just to wrap this up, kind of what that would look like on our graph. So come in here. Again, we had the right kind of look, but our period was 2 pi. So if we come back in here and add in our b value, now let's look at what we got. Our ride starts at 0. We go all the way up here to 100 feet. That takes about 2.5 minutes, you can see there. And then we come all the way back down and we reach the ground again at 5 minutes. So now we've got exactly what we want. This is just an example. This is based entirely on the graph I drew and came up with. If you draw something else and choose different numbers, you might end up with something different. But that is the general process you would go through to find these values, A, B, C, and D, or in this case, just A, B, and D, and cause it to mimic what you would see on a Ferris wheel. So I hope that helped, Audrey, and good luck with the rest of the assignment.